Solve for values of theta between 0 degrees and 90 degrees. Number 1 says if cotangent of theta is 2, find tangent of theta. As a fraction, 2 is 2 over 1. If you know your quotient identities, you'll know that tangent and cotangent are reciprocals. Therefore, tangent of theta is 1/2. Done. Number 2, secant of theta is 4.5. As a fraction, that's 4.5 over 1. Cosine is the reciprocal of secant. That's 1 divided by 4.5. It is not acceptable to have a decimal in a fraction. If you multiply the top and the bottom of the fraction by 2, you get 2/9. Therefore, cosine of theta is 2 over 9. Number 3 is a little different because it's not a reciprocal, sine and cosine. Sine of theta is 1/2. That's y over r. If you draw theta in quadrant 1 and you label y as 1 and r as 2, I'm trying to figure out what x is because cosine is x over r. Using the Pythagorean Theorem, you're going to find that x is plus or minus the square root of 3. We're in quadrant 1, so it's positive square root of 3. Recall once again that cosine of theta is x over r. Therefore, cosine of theta is x, positive square root of 3, we're in quadrant 1, over r, which is 2. Since I didn't do this in a logical, I didn't write it in a logical order, you should number your steps. Step 1, step 2, step 3, and step 4. Number 4, cotangent of theta is 0.8. As a fraction, that's 8/10, which reduces to 4/5. Since cotangent is x over y, we're saying x is 4 and y is 5. Don't know what r is. If we use Pythagorean Theorem, we can figure out what r is. 16 plus 25 is r squared. 41 equals r squared. R is plus or minus square root of 41. We're in quadrant 1, although it doesn't matter what quadrant we're in. R is always a positive number. Therefore, cosecant of theta is r over y. Therefore, cosecant of theta is positive square root of 41 over 5. Number 5. Sine of theta is 40 divided by 41. Find tangent of theta. Sine is y over r. Therefore, y is 40 and r is 41. To find x, use the Pythagorean Theorem. 40 squared is 1600. 41 squared is 1681. Therefore, x is plus or minus 9. We're in quadrant 1, therefore it's positive 9. Tangent is y over x. That's 40 divided by 9. Number 6, cosine of theta is 3/5. So x is 3 and r is 5. Using the Pythagorean triples, that makes y have to be 4. This is a 3, 4, 5 special right triangle. If you want to use the Pythagorean theorem and figure that out, you can, but you're going to figure out that it's 4. Tangent of theta is y over x. So tangent of theta is 4/5. Number 7, cosine of theta is 3/5. That's x over r for cosine. So x is 3 and r is 10. Using the Pythagorean Theorem, you're going to get 9 plus y squared is 100. Therefore, y squared is 91. Therefore, y is plus or minus the square root of 91. We're in quadrant 1 again, so it's positive square root of 91. Cotangent, which is x over y, would be 3 over the square root of 91, which if you rationalize your denominator, multiply the top and bottom by the square root of 91, you get square root of 91 divided by 3 for cotangent. 8, sine of 665. It's different directions. Express each value as a function of an angle in quadrant 1. I suggest to find a coterminal angle anytime your angle is bigger than 360 or less than 0. You don't have to, but I'm suggesting it. 665 degrees minus 720 degrees is negative 55 degrees. Just contradicted myself a little bit because this is below 0, but I think it's a fine angle to use because it's easy to find in the coordinate plane. Negative, so we go clockwise. We're in quadrant 4, negative 55 degrees. In quadrant 4, x is positive, y is negative, and r is positive. So this reference angle, the reference angle for negative 55 degrees is 55. So we got sine of 55. And then in quadrant 4, our y is negative and r is positive, so this is a negative answer. So once again, what you're looking for in these problems, you need an acute angle, which is found by taking the reference angle. Then you need to determine for that trig function what is the sign, positive or negative, of it in that quadrant. In this problem, because we're in quadrant 4, and in quadrant 4, sign is always negative. Number 9, tangent of negative 342. I suggest finding a coterminal angle, although you don't have to. If you had 360, you're going to get 18 degrees. That's in quadrant 1. Quadrant 1, x, y, and r are all positive. Our reference angle is 18 degrees, and it's positive, because in quadrant 1, tangent's positive. Number 10, cosecant of 850 degrees, coterminal angle. If I would subtract 720 from this, I would get 130 degrees, which is in quadrant 2, making my reference angle 50. 50 and 130 is 180. In quadrant 2, x is negative, y is positive, and r is positive. Cosecant of 50 is our answer, because 50 is our acute angle, our reference angle, and cosecant is positive in quadrant 2.